Pull up the clip of Jensen demoing Perplexity Labs.
I've pulled up a YouTube video showing Jensen demoing Perplexity Labs at GTC Paris. It should be at that moment
to
now.
formulate what is now agentic AI. Let's take a look at one example. Let me show you something. It's built on Perplexity, and it's super cool.
Recording
good.
in progress.
There's one more important thing that I want for you to think about. There's one more thing that decides the reasoning ability or some kind of an ability that lets the agent stop after thinking or answering. Come on, think, everyone. Any more leads? Prompt, logic, nope. Context is already part of memory, right? Memory is given as a context. The ability to loop itself. What do I mean by that? The ability to loop itself, in other words, means that it exactly knows when to stop thinking or going into the loop of understanding or reasoning out itself, and it exactly stops there. Make sense, everyone? Iterations or looping, right? So if you look at the other words that you have given to me, let's decode it one by one. Context is given in, okay. Why is this too much? Context is given to the agent in the form of memory. So context is also correct. Tasks. Tasks are part of the prompt. So it is not part of the agent by definition. So you give a task to an agent, right? So it is not part of the agent necessarily. So I'm going to put a cross mark in here. So trigger for any agent or trigger for any LLM is your prompt. So it is never a part of your agent. Response, sure, agent can respond, but it is not the element. It's an output. Okay, it is not part of the agent. Execution, yes, it will have to execute your, like, kind of take all of the necessary inputs and execute, kind of orchestrate or whatever that is to get your response. Rules, maybe you can define rules as a part of the system prompt, but yeah, maybe I can consider like a maybe, not a straight yes, not a straight no. Planning, again, similar to rules, you can define or not define. Is this clear, everyone? Okay. Wonderful. Benchmarks is for validating how much the LLMs are good, not for the agents. Okay, wonderful. Great. Awesome. Now, great. Now that we have understood the fundamentals of agent and LLM, let's go into the discussion of a couple of more things. Okay. Let me ask you another question. How many of you used, I'm seeing your chats, everyone, don't worry. The chats are coming directly to hosts and panelists, right? So everyone's is clutter-free. Everyone's chat is clutter-free. Yes. Cool, lovely. Now, in that case, let me ask you another question. How many of you used Chat GPT in and out? At least different features in Chat GPT. Lightly. Okay. Basic. Okay. Slight. 40%. Somewhat. Okay. Interesting. Okay. Awesome. Sure. I'm going to show you a couple of things. But what are the different types of things that you can do with ChatGPT? Can you just give me as a response? Whoa, one sec. Okay. Text generation, sure. Image generation, sure. Deep research, okay. Any more? Guided learning. In other words, it's called study mode. What are the features I'm asking? Not all the things that you can do with ChatGPT. I'm saying, what are the features of an app? Custom GPT. Okay, you can use custom GPT made by others. Thinking mode. Okay. Web search. Lovely. Any more answers? Connectors. Okay. Reasoning is part of the model. Canvas. Very good. Voice input or voice processing, in other words. Yeah, text and code generation. Let me write it this way here. Any more? Any more? Any more? Anyone? Memories. Lovely. Very good. Okay, personalization. This is not mentioned anywhere. There's another thing called personalization. Okay. Now I'm gonna walk you through all of these things in ChatGPT so you become a power user by definition. Right? I want this first so I can go into the next set. So let's go and open the ChatGPT. So this is, of course, the ChatGPT Atlas browser, but now I've opened ChatGPT. If you closely watch, I'm gonna stop the chat for a moment here. If you're gonna closely watch, I can give a use voice mode as an input that will be transcribed as a prompt. For example, hey, hi, how are you? Are you able to hear that?
Yes, I can hear you just fine. Let me know what you need.
Right? So this is a voice node where you can actually have a conversation like this. So automatically whatever you say, it's going to happen here. The other one is voice input. I can just dictate, hey, hello, hi, everything is so going good or not. Second, something is fishy with this. Let me refresh. Hey, hello, hi, everyone. How is it going? Oh, wow. This is translated into Urdu, but I don't know why. Okay. The other one is, if you watch closely here, of course, you can add photos and files and ask it to extract. There's something called as deep research. If you look into the deep research, I have only 5 left on a plus plan, or like I think in a plus plan, you'll get about 15. That's all per month, and more available on December 15th. Right? This is one feature. The other one is creating an image. You all know that. Thinking is more of I'm giving the chat GPT more time to actually loop itself. So when we go back to the agent as a node or as an ability, we spoke about how looping is one of the key features of an agent to know when to stop and when not to stop. So by actually making it in a thinking mode, I'm asking agent explicitly to think a little more than what you already do. So I get a better response by definition, right? So in other words, all these features are here to kind of reduce the hallucination given the use case. Okay. The other one is study and learn. I can ask about, hey, can you break down Archimedes principle for me with an example that actually suits you, right? Let's say, for example, you are from a mechanical engineering background, and if you want to know a computer science concept, and if you want a similarity or analogy to be given, right, you can actually give that, hey, I come from a mechanical background, but I want to learn something related to, let's say, maybe, I don't know, cloud computing. Now, in the study and learn mode, you will find that this use case is much more fine-tuned to give a response that actually works and simplifies the concepts like absolutely brilliantly. Like in my testing, when I'm learning any new concept, I find myself coming back to this every now and then, right? This is one of such features. I would strongly recommend for all of you to do this when you're learning a new thing. Now, if you go to the more, you see something called as web search. You all know that web search, when I ask about who is the, let's say, Prime Minister of India or something. So now it will go to the current web search that is accesses the web to get the relevant information and crunches that relevant information to give me an answer. That is all about web search. And the other one is Canvas. Let me check. Canvas is all about, if I ask it to write a document, if I ask it to, write down a piece of code so I can preview that a landing page or an app, that is where you use Canvas. So you can consider Canvas as some kind of a, browser based Google Doc where your designer or engineer sits right in. Okay, so when I ask for something, the designer or engineer takes that away and probably edits that particular document right off the bat in the real time. So you see the changes. So it's more like Canvas, like in the literal terms, right? And the last, not the least, is these connectors. How many of you know that you can actually connect your Canva and design your presentations using ChatGPT as we speak today? The chat is open. How many of you know that? Didn't know. No, exactly. So I would strongly recommend for you to do that. Your life will be much more simplified. The current configurations are Spotify, Figma. And if you go to the settings section, under settings, if you go to apps and connectors, you can connect your Canva. You can connect even Coursera and booking.com and these terms. So you can actually say that, hey, at the rate Coursera, can you tell me what are the best courses I can learn for cloud computing? At the rate Canva, can you design a wedding template for maybe some invitation, right? And you can give some elements of what is something that you like, and you can actually just connect them. I want to show that in live. So let me click on Canva, and maybe let's click on connect. It'll ask me for a sign in. Let me continue. Give me a moment in here. I'm going to allow this. Canva is connected. My Spotify is connected. My Figma is connected. So let me go back, and I'm going to say at the rate Canva, or I can just say Canva, I guess. Okay, let me refresh. Yeah. Okay, Canva, can you make a wedding template for a South Indian wedding with bride and groom names as, I don't know, Ashrita weds Arun. I'm just giving a random example in here. The date of marriage is tomorrow. I don't know what tomorrow it'll take. Let's see. Ensure to keep the fonts and themes elegant and minimalistic. Now it will connect to my Canva. It is going to get the templates. So if you see, it is going to open a simple browser inside my Canva, and it is going to spin off these things right off the bat, directly integrate directly talking to Canva behind the scenes. I don't have to switch my tabs anyway. Let's see what it is going to give. Yes, can you see this, everyone? Now, if I click on this, if I just click on everything in here, I can directly open in Canva and edit right off the bat. Is this cool? Is this powerful? Everyone? Like imagine like you're just talking to Canva right from Chat GPT. You don't have to just go to Canva anymore now. Like look at the progress of Chat GPT becoming a super app in the coming days. Right? Yeah, this is Chat GPT Go plan. Like this is a free plan for India, right? For an year. So people who are from India who are staying in India, ChatGPT is giving 1 year ChatGPT Go plan for free until November 2026. So this is all inclusive in that, right? You can exactly do the same for Figma designs. Probably you can connect your Figma and say that, hey, can you check the latest design and probably help me edit so and so things? Or you can go to Spotify and say that, hey, can you give me a wedding playlist for Telugu family South Indian wedding, right? It'll get everything. Go to Spotify, connect with Spotify, list out everything and give you a playlist. This is free Canva, free ChatGPT. Like nothing, no strings attached. Yes. Cool, everyone. Is this powerful? Yes. Did you learn something today, especially with regards to ChatGPT? Yeah. Wonderful. Wonderful. Excellent. Great. Now let's move on with the same enthusiasm. Let's move on. I want to talk a little bit on deep research. Okay. We have seen all the other things. Of course, these are things that are, that can be played around a little bit. Is it free for Indians abroad? So maybe you'll have to connect to India and VPN, I guess. Yeah. Okay. So now we'll have to think about a deep research, like how it runs behind the scenes. I'm going to talk about that in just a moment. Right. Now, before I do that, I want to talk about a last thing. In the personalization, go to settings under personalization. you can give ChatGPT a very good personalization on what are the, like, for example, should it be professional with all its responses? Should it be friendly? Should it be candid? Should it be quirky, efficient, nerdy, cynical? Like, you can define these presets. On top of that, add a custom instruction saying that, let's say I'm a Marvel movie fan. I come from mechanical engineering, and probably I'm interested in, let's say, cricket and let's say badminton, and you can give a couple of more things. So now next time when it is answering, it will take this as an input. It will see that you need a very candid or a friendly conversation, and it will try to give the examples related to your domain of interest, related to your custom interest, right? You can also give your nickname. You can, I think there were a couple of memes coming in where the nickname is, they fed it as baby or something, and then every single time it responds, hey baby, how are you? Right? But it is what it is, right? I think this is something you should actually look into when, if you want to become a much more power user and get more out of ChatGPT in the day-to-day practice. Okay, so this setting is in your settings. Under settings, go to personalization. This is where you can play around with this particular thing. And for those of you are asking, how about connectors, Akhil? What are the connectors? You can configure the apps and connectors here. You can say what are the apps you want to continue or connect, and that will take the show forward. Are we all good until this point? This is only available in ChatGPT as we speak. Let's move on. Yes. Okay, wonderful. Perfect. No, I think eventually LinkedIn or other apps will come up. This is just the beginning, right? Okay, wonderful. Now, let's get into the deep research context. Okay, I want to talk a little bit on deep research and what it is all about. So let's do that. Able to move. 1 second, folks. Okay. Deep research. Before I talk about this, how many of you tried deep research? At least once. At least once. How many of you tried deep research? Okay. Used it with Gemini. Any app, it doesn't matter. Deep research in any app. Yes, you tried so many times. Okay. Yes, I tried for preparing a trip plan. Lovely. Good. Can I say that in every deep research, it will take about 15-20 minutes for an answer to generate on an average? Can I say that? Sometimes even more. Okay. Right, absolutely. So on average, the max time capped for a deep research is about 15-20 minutes, right? About 10 minutes. And it will say that, okay, we've got the request. We will ping you when the deep research is ready, etc., etc. Correct? Yeah, I asked for analysis of a market and gave it an idea that I had. It took 10 minutes. Absolutely. 10 minutes is, I think, an average, right? So let's break down what are the constituents of a deep research. Let's break down what are the constituents of a deep research and understand how things will flow from one end to another end. Okay, I'm going to put the chat on hold for a moment here, right? I will explain one thing at a time. I need your laser sharp focus, right? So laser sharp focus should be your keyword to pay attention for 5 to 10 minutes, and then you go back to chill mode. Okay, cool. Awesome. The chat is on hold. Now, first things first, whenever you give a prompt as an input, let me put this to black. This is the prompt as an input, right? The moment you give prompt as an input, first thing the deep research enters into is a planning mode. First thing is all about planning. Okay. Now, let me ask you this question. What do you think planning mode will contain? Let me put that question in here. Of course, I'm going to answer what are the main elements of this planning mode. What do you think this planning mode will have, especially in a deep research context? Come on, everyone. I just wanted to know your answers. There is no good and bad, like whatever you have it, just put it across. Okay. Absolutely. Order of tasks, what website to search, correct? Correct. Lovely. Execution time. Okay, maybe. Break order. Okay, break prompts. Lovely. Understood. Okay. Good answers. Let me stop the chat in here. Yes, correct. Decomposition. Okay. I'm going to put down everything that what you have said in a simple terms. In the planning mode, it'll understand what to search first. Second, what sources to prioritize. What sources to prioritize, as in saying that, let's say if a startup news about, let's say, I don't understand, like, okay, let me give you a reference. In India, we have a local newspaper, right, that runs in every, regional newspapers. And there are like national newspapers, Times of India, Hindu, etc. Now, if you were to hear a particular statement about some company, either making an IPO or going big or something, which source would you prefer higher, the Hindu or the local newspaper, for the source of truth or the trust? Which source would you prefer higher? Hindu, the Hindu, correct? Absolutely, right? For example, in the same way, if I go on an internet, if I'm searching for a startup news, and we have TechCrunch, Y Combinator, kind of updates there, and the other around again we have the Hindu and the national newspapers related to startup news. Which one would you prefer in this case? Again, which one would you prioritize? Is it coming from TechCrunch or Bloomberg or the Y Combinator, or coming from the Hindu? Of course, right? So depending on the theme of the topic, depending on the prompt, it will prioritize what sources to navigate and actually prioritize to look into that information. Is this line clear, everyone? Yes. So what sources to prioritize is one of the important metric that it does behind the scenes. Now, the other one it will do is search queries. So it will play with search queries. What do I mean by that? So if you are searching for how to pet a dog, there are multiple ways you can search for it. Yes, Shilpa, in a way, correct. So how to pet a dog, this is one way of doing things. Or you can say pet dog. Very simple, right? How to pet German Shepherd. Okay. And probably best practices for pet parenting. Makes sense, everyone? More or less, we are in a way kind of using the same prompt or rephrasing the same sentence in different ways, so we get different sources, so we can prioritize different things. Make sense? Is the question or is the search queries element clear to most of you? Everyone? Yes. So it also builds up many different versions of the search queries, so it can get better sources, so it can prioritize better. So the quality of information condensed at the end is much more better than what we usually do. Right? So usually in search queries, it'll probably do about a 10 to 15 versions or varieties of search queries. That usually works with majority of the use cases. Make sense? Is the planning stage clear for most of all of you? Yes, everyone. Come on, energy. I just hope you did not have heavy lunch. What I'm trying to say is, the moment you give a prompt to a deep research mode inside ChatGPT or any other thing, the first step of that deep research mode is to plan. It will plan what to search, what sources to prioritize, how many search queries it can create. It will create about 10 to 15 varieties. On top of that, it will kind of condense everything. So this is all about a planning step. Okay. Now, Once this planning is done, it will now move into one of the important steps called scraping and searching. The actual scraping and searching and happens here. Scrape and search. Let me put it that way. The actual scrape and search happens at this step. What do you understand by the word scrape and search? Everyone, what are your answers? Investigation, scraping, extracting data, mining, web page reading, correct? Scrape means collecting info. Lovely. Okay. Lovely. Read through pages, match data, condensing, correct? Filtering, lovely. Absolutely. Wonderful. Now what happens is here, once I plan what are the sources I need to search for, it will spin up multiple sub-agents that can do a parallel scraping and searching. It'll spin up multiple sub-agents that can do parallel scraping and searching. Okay, what happens is, first, parallel web search. Second, what happens is the other one. Can I say that, would you continue to scrape and search for the eternity of time? Would you continue to scrape and search for the eternity of time? No. Can I say that there will be a timeout for that particular search? There should be a timeout, correct? Otherwise, it doesn't make sense. It just keeps on eating my resources and I don't get anything out of it. Okay. And not only timeout, it will also have hard limits on number of searches. Hard limits on number of searches. For example, if it's a Claude mode deep link, it can go up to 1,000 links for searching and scraping. If it's GPT, it can probably go about 800 links and 700 to 800 links. And if it's Gemini, it'll go max of 900 to 950. You can write 950 links, 1,000 to 1,100. Make it like this way. Okay. So what do I mean by this is that in this step, they will have a timeout, maybe 25 minutes or 30 minutes. We don't necessarily have a clear idea because we did not probably build that system prompt for the deep research for it to max out the performance, right? So maybe the timeout is around 35 minutes is what I'm guessing. Then the hard limits, it will maximum search about 1,000 links. And my question to you is, let's say if it completes searching 1,000 limits in under about 5 minutes, right? Let's say, example, it searches everything in under about 5 minutes. Can I search for more? Everyone, can I search for more? It's a question. For those of you who said yes, you're wrong, because there's a reason why it's a hard limit. Even it doesn't matter even if you're searching in 5 minutes or 10 minutes, the hard limit is 1,100 links. Okay, irrespective of time. So why 1,100 links is a max? Why can't I search 3,000? Why can't I search 5,000? Right? So there's a law, I think I don't remember the Moff law or something, that says that after a particular tipping point of source gathering or requirement gathering, right, the quality of information that you're going to get will be like hardly any 1% improvement more than that. So let's say if I've read about 1,000 articles that says how to pet a dog, don't you think I got a pretty much understanding of what are the varieties of information that exists on the internet with regards to how to pet a dog in a better way? Yes, no, maybe. If I add another 1,000 links, don't you think it is a very redundant information for me because I've already understood the pattern? Yes, no, maybe. Absolutely. Correct? Exactly. So the hard limit is number one, because the value of information or the quality of information you're going to get after that hard limit is probably less, like very minimalistic in nature. If we need it, we will do it. but I'll come back to that particular looping in ability later. But that is one. And the number one timeout is because we don't want to run more infrastructure and spend more cost if it is not relevant to that particular execution, right? So this timeout and hard limits keep a check on the cost by definition. Make sense, everyone? Yes. Lovely. Are we all aligned until this point? Wonderful. Great. Now, once this is done, once scraping and searching is done, it's time for us to collect and consume the information from these links that we have scraped and searched for. So we have a consumer mode or a step. What does this consumer mode or a step do? Let me write it down. Time to laser focus. Put your laser sharp attention for 5 minutes in here. This is very important. Number one, it finds relevant links. Okay, it finds relevant links. Number two, it will remove duplicates. It will remove duplicates. And it will rank the info based on different parameters I'm going to talk about right in just a moment. And it does a parallel summarization. So everything is under 200k tokens. I'm going to talk about that in just a moment. Let's go one by one. Finding relevant links. What do you understand with this statement, everyone? Let's say we found 800 links. 800 links from my search query that is related to our prompt, right? Out of 800 links, maybe only 200 links are relevant to my prompt, correct? Out of 800 links, maybe 200 are relevant to my prompt, right? So first things first, we'll find relevancy, okay? Or it could be less to perfect, yes. And second, even in that 200, there might be duplicates, right? How to pet a dog and how a dog can be pet. Example, I'm saying active voice, passive voice, probably some kind of a rephrasing, some kind of a similar pattern, but jumbled across the pages, right? These are duplicates that I don't need by definition, right? So consumer is all, what is the job of a consumer is to kind of filter out the noise, So it will only fetch the relevant links out of all the things we have scraped and searched for. It will remove the duplicates, and it will rank the final links. So ranking also happens here, or in other words, prioritization also happens here, saying that these are the things it will prioritize on. Number one, quality of source. Quality of source says that, again, the Hindu Y Combinator, the example that I give, right? It will rank according to the sources at hand. And next one, it will also do a keyword search, right? It will also do a keyword search. So for example, if an article has more keywords related to my prompt compared to an article that has less keywords related to my prompt, it will prioritize the first article over the second article, right? And on top of that, it will also consider recency of the article. It will also consume recency of the article. So it is giving the relevant information at the time of your prompt. How does it know what is the quality of source? Is that trained from before? No. This is kind of an algorithm you can consider behind the scenes, running behind the deep research mode before it is fed into the LLM. So this is all happening before it is fed into the LLM. This is a complete different structure. This is a complete different agent. This is a complete different agent. Okay. So this has some kind of course, some model, some not necessarily a ChatGPT model, could be some custom model that they've developed only for these purposes, right? Yeah. Is this clear, everyone? The consumer until the third part? I'm going to talk about parallel summarization in just a moment. Lovely. Clear. Now what happens is parallel summarization, in other words, means that let's say you have scraped or searched for 10 articles. Okay. Let me put that 10 articles in here. 2, 3. I'm going to copy all of this and paste it here. Here. Okay, let's do 9 for now. Okay. Now, what happens in parallel summarization is this all is happening in the scrape and search format. Scrape and search, we get all these links from. Now, consumer has to consume the information from this particular links, right? How will it do? After it does the cleaning of relevant links, removing duplicates, ranking, now it will try to parallelly summarize the information. So let's say this is the overall prioritized list or the custom list or filtered list of links, filtered list of links for the input as the consumer. Now, what will it do is it will do a divide and conquer. I'm just giving an example for you to make more sense. What do you mean by that? So it'll probably consume these 3 articles, right? And probably summarize the entire jinx or gist of that particular articles under 200k tokens. Under 200k tokens. Why is this? Because the context window of an LLM like Claude or something is about 200k. That's typically about I think 800 to 900, like 8 lakh to 9 lakh characters, like 800k to 900k English or alphabet characters. Alphabet characters. 800k to 900k. Let me put it this here. Make sense, everyone? Yes. So for the model to kind of consume, it should need less than 200k tokens only, else the information will be cut off. So let's say if you give a 1 million alphabet English characters, it'll only probably take up to 900k characters and the rest of is ignored. Make sense, everyone? This is the context window of a model. It can only take an input tool as long as 200k tokens. So what this consumer does is it will try to summarize all the information from these 3 links under 200k tokens. Okay. Now I'm going to cut this out here. So, okay, let me put it as 1. It will do the same thing for all the other articles also. I'm going to put it here. I'm going to put the other one here. So this is for 3. This is for 2. So now what happens in here is after total is 200 or is it for individual links? So consumption of all these 3 is under 200k tokens here. Is under 200k tokens. So now what happens is again these 3 information are even more summarized. Even more summarized to get another summary that is again under less than 200k tokens. So now if you overall look at the number of links, probably let's say if it is, let's say 300 links, it'll do this parallel work at every single step, probably divide and conquer or some other algorithm. I'm trying to just put out some parallel processing in here. Okay. Now what happens is since the entire summary for the 4th time is less than 200k tokens, now this is fed as an input for the writing or the actual LLM. Is it making sense? Everyone, is it making sense? So far, so good. Are you all with me? Right? So if you look at the complexity by definition, at least in this step, right, don't you think it has to crunch down so many things at once, like so many parallel processing or sequential processing at once, and it has to crunch down everything to under 200k tokens so the model can understand and produce an output, right? Now, do you appreciate or now do you think that why it takes about 5 to 10 minutes by definition for a deep research? This is again, we are at the mid part. We did not get into the next parts, right? Yes, lovely, fair, wonderful. So now what happens is right after consumer, now once we have parallel process, so summarized everything, that input will move into the next set of mode or sub agent or step called writer. So these are the actual writers of the information that is consumed, right? So now whatever the information that we've got at the fourth iteration here is passed as an input to a writer now. So now that input is read by the writer. Now here what happens is, if you look at the output, of these deep research model, can I say that it's at least about 15 to 20 page long output, like a proper solid research with so many things in that? Make sense? Yes, no, maybe. Hello, everyone. Right? Like if you have tried, at least you'll see that 15 to 20 pages worth of characters, right? But even if you're asking for a simple model like ChatGPT, it cannot do that. How is it doing it? It's again following the same action. So, for example, if it has to build a 25 section document report, if you have to do a 25 section document report, what happens is writers will spin up, or consumers will give that writing ability or that particular plan of action to maybe or 5 to 6 sub agents, saying that, hey, first agent, you build the articles from 1 to 5 or the sections from 1 to 5. Hey, second agent, write from 6 to 10. Third agent may be writing from 11 to 15. Fourth agent may be writing from 16 to 20. So that how 4 agents will complete the 20 section report. Make sense? So writers, or in other words, writer subagents does the work parallelly. Okay? Make sense, everyone? Are you all with me? Yes, wonderful. Now, the other one is when it is writing something. Okay, let me give you a question. Let's say if you're writing an article, you found your own research, maybe out of 10 articles, you want to write something. And at the mid of your writing, maybe you lost a data point, right? How would you find the data point in general, in a normal world, in a physical world? If you seek a data point saying that, hey, the maybe I don't know, Zomato grew by 200%. But if you don't know that 200% as a metric, how would you find it in general? It's a question. Search, Google search, ChatGPT search, correct? Yes. So can I say that if the writer needs something, sorry for that. If the writer needs something, if it does not have the info, can I say that it should have to go back to this scraping mode again and say that, boss, I don't have an input, go and scrape the information for me so it can be consumed and come back to me? Make sense, right? So this feedback of collecting the data from the search mode and the scrape mode, right, is like this. The writer agent is completely based on prompt. What do you say? How much relevant, or how much information it has with regards to the prompt. So it is completely based on prompt based feedback. Let me write it this way, sorry. Prompt based feedback. So prompt will guide the writer agent that, hey, I don't have the information, so you better go and find that information and write it for me, right? So that's the reason why the feedback number loop one comes in, right? As I've already told, maybe they have different algorithms to write, or segregate what sections or what things goes to a different sub agents or sub writers. So essentially they will write everything parallelly. I think I've already done that, right? Yeah, makes sense. And I think on an average the number is about 35 to 40 section report. I was reading some Twitter article, Reddit thread the other day. It mentioned that it can do a maximum of 35 to 40 sections report based as a response out of deep research mode. Are we clear until this point, everyone? Are we clear until this point? Yes, yes, clear, clear, clear. Now, the last but not the least is writing. Writing does not mean that it has done everything in correct fashion, right? So to have another round of pre-check, do another round of pre-check before it produces an output, it will also have a validator mode or a validator agent. Its job is to check these things. Number one, of course, scans the entire response. This is what it does, scans the entire response. Second, it validates the info. Third, it ensures citations are provided properly. Or in other words, links and sources are well defined, right? And it will ensure if the writer agent has written or if the output is actually writing or producing an output that satisfies the user prompt. Makes sense, everyone? Are these 4 points clear? First, it scans the entire response. It validates the info with the necessary links that it has got, and checks if the citations are actually provided. So if you see that 1, 2, everything has a hyperlink given at every step, that is what it is. And it checks that if the output is actually producing that it satisfies the user prompt. Like, is it actually ticking off all the checklists that is given by the user? And if it is answering every single thing that user might have thought of, right? Okay, makes sense, everyone? And then once it is come from the validator, this is the final output you see in the deep research mode. This is the final output you see in the deep research mode. Is this a better map, everyone, for you to understand how does an input and output in a deep research works? How does an input and output works in a deep research context? In other words, deep research is a form of an agent that has different agents at its disposal, but it is well defined, saying that first you have to do this, second you have to do this, third you have to do this, fourth you have to do this, fifth you have to do this, and then give. And for every sub-agents or modes or processes, there's a well defined task list or rules that guide or that help that particular mode to perform at its best, right? And you might be asking, Akhil, what about if we can combine consumer and scraping mode, don't you think it's a better option? If you combine consumer and writing mode, don't you think it's a better option? See, there could be hybrids. There could be an implementation differences. There could be optimizations that can be made on top of it. This is a higher level representation that will give you a very good understanding of how things from like input to output. I'm trying to map out the black box that was never seen out to the world, right? So these are the elements of the black box. So this is one way of doing things. There could be 100 different way of doing the same thing. Maybe because of better optimization, maybe they want to reduce even more coster. Maybe they have seen some more statistics that says that, hey, most of the time, even if I'm doing 500 links, maybe user is not satisfied. Maybe I have to bump it up to 600. Or if you're doing 500, user is always satisfied. Let's reduce down to 400 links as a hard limit now and check if the user response is same as is, right? So companies will be playing with hard limits, timeouts, different logics, different optimizations. But this is a higher level representation for you to understand how deep research will work. Make sense, everyone? So this is the reason why, since this is a very comprehensive infrastructure heavy, time heavy workload, this is the main reason why in the deep research you have about 5 to 6 per month. Per month, right? Because it costs a lot of money for these companies. And if they give you 100 deep research, like they are bankrupt tomorrow, right? Yes. Could you display the diagram? Yes. This is the diagram from end to end. 1 second. Here you go. I think this is the input, this is the output, correct? Here you go. I'm going to put this screen here for a moment. Let me zoom out. Okay. I'll count backwards from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? I hope you have taken the screenshots. Right? Lovely. Awesome. Now, everyone, are you all alert? Are you all alert still? Yeah? It's not going bouncer or over the top of your head. Okay, let me ask you this question. If you are alert or not, what is the first thing I've asked today? What is the first thing I've asked today? Interesting, interesting. Most of you say, what is agent? Most of you say, what is agent? Okay, I think the first thing I've asked is, I think some of you said, how are you? I didn't ask you, how are you? I was hoping that you all are good because you've joined on a Saturday evening, right? The first thing I asked is the expectation clear to that, you have to answer my questions and everything for the session? Yeah. That is the first thing I've asked today. Yeah. Great. Okay. Oh, yeah, man. But that is the normal words. But yeah, that was the first thing, like literally. Right? Yeah. Context was not set correctly. Lovely. Awesome. Cool. Yes, everyone, I think that was an alert check in between. I find I find myself doing that every now and then. Okay, lovely. Now let's go to the next concept, right? That kind of builds on top of this, right? Now let's go to the next concept that builds on top of this, right? Now let's understand what are the different things of agents or different forms of agents that we can build or play around, especially in the context of orchestrating them. So if you look at the deep research from beginning to end, can I say that it is well defined and well orchestrated with a very good task list or roles and responsibilities at every step? Can I say that? Yes. So if this is done for a deep research node, there must be some different patterns. There must be different frameworks, different optimizations that are out there that we might use for different use cases, right? I'm going to highlight them. And that is where we dive into the crux or the main agenda of the session, agent orchestration frameworks, right? I'm going to title down here, agent orchestration frameworks. I'm going to bold this up. Okay. Agent orchestration frameworks. Let me put this in here. What do I mean by that? So I'm going to show you what are the different frameworks that exist out there that is doing the jobs that are necessary for us, but different use cases. Okay. Or it could be that same way of doing the job, but in different forms, right? You can take it anyway, but I'm going to show you different frameworks. The first thing is, let's say in the deep research mode, everything is one step after another step, correct? Of course, from the way we see it, it's one step after the other step. So this mode of operandi is called a sequential agent orchestration. Sequential agent orchestration, right? What do I mean by that is, these agents are sequentially connected to each other. They are well defined. They have a very good scope. They have some kind of a feedback loop as necessary. And that is more of a sequential agent. Sequential agent, for example, like let's build up a conversation to probably solve an engineering. Most of you are from engineering background. So in that case, let's say that, okay, a client wants to build a static website. A client wants to build a static website What are the different steps that we do, especially for a static website inside a company, right? Can someone address that? I want to know what are the things that you find yourself doing or inside your company if this is the requirement. Who is the first point of contact for this kind of a requirement or to take this requirement? Come on, everyone. Come on, come on. Okay, we have the answers. Most of you say business analyst or a product owner. Okay, let me write it, product owner. Product owner takes the specifications from the clients, right? And who will he get back to after this? After this, who will he get back to? Will he directly get back to developer or will he talk to the architect? It could be a front end or a back end architect, doesn't matter. In this case, everyone remember it's a static website. We don't need an architect. We need an architect for a back-end development, right? Who do we need in here? Yeah, designer. Absolutely, sir. Yes, because it's a static website, nothing fancy in there. You need a UI UX front end or a very good senior designer who can design that particular UI UX for you. Correct? Once that happens, where will this go? Figma people. Okay. Yes. Who will do that? Okay, developer, absolutely. What sorts of developer? Front end team. Okay. So front end developer. I'm gonna write it here. Front end developer. Next, what happens? Next, QA. Okay, QA or testing, in other words, correct. QA. And then yeah, DevOps. Yes, boss, correct. Deployment. Yes, you'll have to deploy this in one of the client instances as in the way they need. Correct. So deployment or DevOps. Correct. And after that, of course, we'll probably get a feedback from client or whatever that is. So probably this is the end goal where we share the first draft of the client. Correct. This is the go live phase. Can I say that if I build an agent that is doing the product owner function, that is one set of agent that does the product owners, one set of agent that is specialized in designing, one is front end developer, one is QA, one is deployment. Don't you think I can connect them sequentially to solve this problem? If not best, but at least 50 to 60%. Correct. I just have to well define them, well scope them, well test them, and deploy these agents. Correct. So for a sequential agent, how do you define them? How do you define them matters more. Correct. Lovely. Now, there is another form of agentic framework or agent orchestration framework that is called parallel agent pattern or something. What do I mean by that? But they have to be in a coordinating from the brainstorming session. Yeah, but you know it, right? You will define this. So for example, in your company, let's say, if you have developed this sequential agent that only solves the static website use cases, don't you think that is already well taken care of? Yes, no, maybe, Wasif? Yeah, that's what I'm talking about, right? This is use case. For that use case, we have defined this, so it is sorted, right? You can do the similar job right now. You can do the similar job of this. Let's say if I have the entire same thing in here, instead of sequential, let's say if I have a bunch of tasks at hand. One is static website. The first one is static website. The second one is maybe UI UX patch. The third one is probably front end, or I can say, you know, optimizing the or rendering speed bug. Okay. The fourth one is, let's say, some performance degrade, performance bug. Yeah, sure, yeah. Fifth one is, let's say, some CI/CD pipeline broke. These are the 5 tasks at my hand, let's say, right? In the case of a parallel, what will I do is, what will I do essentially is, let me copy this, all of it. Sorry. In the case of a product like parallel execution, since the first touch point of this particular product owner for this first use case is the first touch point, I'm going to first assign that task to this, right? And I'm gonna do read out all the tasks and distribute first. So I'm gonna do this to this. Second is second. For third, render and speed bug, this one. For fourth, and then fifth. Okay. Now look at this. Once a UI UX patch is made, don't you think that should go to a front-end developer for developing that? Yes, no, maybe everyone. Yes, correct. And even for the static website also, once the product owner takes the requirement, it will go to designer. So if you look at it, the parallel will have these jobs for all of them coming in, ready for them to actually go and execute. And now once that is done, the designer, since he's solving the UX patch, probably he'll have work for developer and QA here. And now since it's a performance bug here, this task is assigned to QA and development, and this is for fourth. Now, if you look at this, the deployment agent is actually solving all the tasks, but in a different priority order, given the number of tasks at hand that you have distributed it. Makes sense, everyone? So this way we are saving time. We are not working like one sequence at a time. Correct? Yes, no, maybe, everyone? So this is one form of doing things. Again, product owner has less job always. Yeah, very smart. Correct. Lovely. So this is parallel agents pattern. The other one is sequential agent. Now, so this is something works well if I have well defined all of this particular agents and all that. But let me ask you this. Your company, who is that person who kind of delegates and manages the people or assigns the task to the people and reasons him or her out to actually say that, okay, this task goes to them, this task goes to them? Come on. Team lead, architect, manager, project manager, product manager, delivery manager. Yes, correct. Right? Can I say that there is some kind of a manager who can reason out for you and say that, boss, this is the flow you need to follow? If that is taken care of, don't you think that is a very good match for you in the ideal case? Yes, no, maybe, everyone? Correct. So what the other form of orchestration is called orchestration pattern itself, or manager, or what do you say? I think master slave kind of, no, not master slave. Yeah, you can just say orchestrator pattern. So what does this mean, right? You have a master agent. You have a master agent who can reason out for you. You have a master agent who can reason out for you. So let me put the master agent here. That is manager. Right? That is manager. Now the manager has access to this agent army. Okay. Now the manager has access to this agent army. Okay. Oh, sorry. One second, everyone. I'm a little OCD on these things, so please bear with me. Okay, cool. Yeah. So now that the manager has access to these agents, don't you think this manager agent will be dynamically be able to do a parallel processing and reason out itself, instead of we defining the tasks and the responsibilities for these agents? Don't you think, depending on the use case, the manager will say that, hey, that task will first go to developer, or a designer or a QA or a deployment, right? And from there on, manager will assign that, okay, once you have done the work, send back the work to me so I can delegate that work back to again front-end developer. Make sense, everyone? Right? So this kind of a orchestrator pattern is much more useful, where we need another sort of an intelligence layer to reason out the scope and define the workflow and or the sequence or the pattern for the given use case at hand. So no matter what use case is coming in, this manager agent will be able to kind of figure out itself and say that, okay, this will go to product owner. Then you don't have to do designer, front-end developer, QA. This is just a deployment thing. So probably product owner directly gives it to deployment guy. Right? Make sense? Everyone? Right? Hello, 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 hello. Yes, this is one of the pattern. Okay. So manager creates tasks and assigns them, and lower agents follow instructions pretty much. Correct. Okay. That's exactly manager for you. Right? Yeah. It's like telling agent what to do, not how to do. These agents know exactly how to do. They just know they just have to know what to do. Product owner agent knows how to do the project related things, no? Already. Yes. Now, let's go into different set of agent framework that is called graph pattern. How many of you know what is a graph or heard of it? I'm sure most of you. Graph pattern. Right? Okay, so this is okay. Let me put a little more. Again, this is completely subjective on my personal joke, right? Consider this manager as a like an MNC company, like well-established MNC company where you have a hierarchy or a hierarchical pattern. This is more of a hierarchical pattern. Okay, the typical MNCs or the big organizations. Now, graph pattern is more of a startup. Graph pattern is more of a startup. Why do I say that? Let's say if I take the same army of agents with me. Okay. Now, one of the things in the graph pattern is, let me put this inside a circle. Yeah, something like this, right? 1 second. Yeah. So this thing is, every agent has a free will to go and talk to any other agents by definition, unlike other patterns. Like this is completely a messed up graph. And every agent has some kind of a reasoning ability to figure out where the next task goes to. Right? This is more like a flat hierarchy or open hierarchy. That's the reason why I said startup. Right? Every agent, or say, what essentially I mean to say is that product owner is intelligent enough to reason out him like that himself or this itself that, hey, probably this task probably next goes to deployment. So rather than going through the designer, front-end developer, QA, I can directly give it to deployment. When there is no manager, it happens. Yeah, when manager is on leave, probably. Correct? So this works best given again different use cases. There's a reason why startup kind of flourishes, right? For different reasons. Correct? Everyone makes sense? Are we all good with the graph pattern also? Yes. Last but not the least, manager eliminated in the graph pattern. Yeah, yeah. The last but not the least is human in the loop. Scrum Master is there. Like I'm just giving an example starting with a product owner. But again, you understand the logic, right? Yes. Now, human in the loop. Finally, the human enters. Yeah, absolutely. Correct. Manager laid off. Okay. Human in the loop. Okay. Now what happens is here, every single output that is generated from these agents, let's say this agent, any other agent, it doesn't matter what is that agent scope or type or task or responsibilities are. If it provides an output, this output must go through a human review or an approval. Human review or approval, right? And then probably human will give a feedback. Probably human will give a feedback, right? Depending on the feedback, we'll do a couple of iterations and then the output is generated. Okay. The output is generated. And this is the output that must be pleasing for all the different reasons. So you will see this kind of a pattern emerge, especially in the finance sector, especially in a pharma sector, where the compliance is one of the must-haves, right? One of the must-haves. Now, what happening? So if you look at the overall structure here, we have on an average about 5 different patterns of, kind of connecting or plugging these agents. Yes, no, maybe everyone, right? There might be more different versions of this, but these are the most important yet fundamental, right? So now what is, let's name this. Let's call the first sequential agent as 1. Let me put it here, 1. This is 2. Okay, this one is very, 1 second. 1. Okay, let's call this 1. Let's call this 2. And we have it here 3, where manager is here. We have another one 4. Where will be investor? You are the investor. You are creating these, no? This is 5. Okay, cool. Now let's try to have a comparison chart for these agents across different mediums. Sequential, parallel, orchestrator, graph, and human in the loop. Okay, lovely. Thanks for that, Muralidhar. Now let's put that in here. Let's put a diagram. And I want for everyone to think a little more harder. Put your brains to test. Yeah. Okay, you want to take a screenshot. Let me arrange this a little more neat. Okay, 1 second. So you can take the screenshot of first sequential and parallel agents. I'm going to put a pause here. Sorry for that. Yeah, I'm going to count. I'm going to count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yes, Shraddha got the pattern, right? Now let's go to the next one. The graph pattern and the manager and the human in the loop pattern all together. Again, counting backwards. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, pattern broke. Yes, absolutely. Yes. Okay, system hung. Please show 1 and 2 again. Okay, first take the 2 screenshot. Lovely. Once this is done, let's take this one. Again, 1 and 2 here. Done. So lovely. Lively class. Thank you, Premita. Thank you. Wonderful. Perfecto. Combined 1. Picasso would be proud today. Okay. Please show all 5. Here you go, all 5. I think they don't fit into the frame here. But yeah, here it is what it is. Perfect. 5, 4, 3, 2, 1. Let's go. Now, time for us to put some logical thinking in here. Okay. So there could be trick questions coming in. Reminder everyone, there could be trick questions coming in. So please pay utmost detail. I'm going to name the agents in here. So first things, all family in one place. Like, okay. Sequential. The second one is parallel. Third one is orchestrator. Fourth one is graph. Fifth one is human in the loop. So this is technically HIL. Yeah, I'm gonna Improve the font. This is readable now. Cool. Now, let's rate this particular agents across different things. 1 second, everyone. Sorry for that. Okay. So the things that we're trying to evaluate these agentic patterns are as follows. First, let's try to evaluate the speed of them. First is speed. The second one is complexity of development. According to you, of course, you don't have a reference right now. But what do you think the complexity could be? How much control you have with these agentic patterns and control over the output. That is what I mean. And the last, but not the least, is cost. Okay, let's do some kind of a gamification process here. I'm going to rate the total. This is the total box. Okay, now how is total calculated? Right? In the context of a speed, don't you think high speed means we should give a higher points? Make sense, everyone? Don't you think high speed I should give a higher points? So for high speed, higher points is 1. I'm going to give high as 1. For complexity, high complexity is 0, correct? So for a lower value, I will get 1. Correct? Now let's do that again. For control, if I have high control over the output, that is a very good thing for me. So for high points in control, I'm going to give 1. And for cost, it has to be low. For a low point, I'm going to give 1. Right? So if it's a medium, I'll probably give 0.5. If it's opposite, it's 0. Correct? Makes sense? High speed essentially is good for us. So I'm going to give a numbering 1. So 1 rating. So if it's a medium speed, I'm going to give 0.5. If it's a low speed, I'm going to give 0. Okay. Yeah, the scale is 0 to 1. Correct. Absolutely, Rajat. Lovely. Thanks for jotting that down. Now, for a sequential agent, what do you think the speed is? Slow, low, very low, 0. Absolutely correct. Spot on. Right? Now, for a sequential agent, what is the complexity? Low. In that case, it is easy to build. 1. Correct? What kind of control you have? Very high control. Absolutely. So I'm going to put a one more 1 here. Correct? For cost, what do you think the cost? Low cost. Simple, straightforward. Correct? Absolutely. So I'm going to put a 0 here. Sorry, 1 here. Low cost. So if it's matching low, it's 1, low, low, 1. So how much total points here? We have 3 for the sequential agent. Okay, there's a reason why deep research is kind of sequential. Look into the patterns. Try to connect. Okay. Now, let's get into parallel. What about parallel? Speed. 1. Absolutely. Bang on. Correct. This is 1. Sorry. What about complexity? 0.5. Medium. Correct. Yes. Lovely. 0.5. What about control? Is it like medium control or completely no control? Medium control. Lovely. Good. Now, what about the cost? Cost. Think everyone. Cost is high or low? High cost, because you're parallel processing so many things. You have to pay for infrastructure, right? So cost part is high. So this is getting 0, right? So overall, this is probably 2. This is, we have got 2 points. Okay, now let's get into orchestrator. What about the speed? Is it high or low in comparison to the sequential and the other agents? Medium, actually. Yeah, absolutely correct. Very good. Now, what about complexity? Complexity. High. Correct. Absolutely. So this is 0. If it's high complexity, I'm going to give 0. Okay. Now, what about control? How much control I have over the output? Think everyone. No, it's not medium. It's high. I have high control. No, there's a reason I've put a manager, so it can definitively kind of figure out which agent to use and give out the best possible output. Manager only resolve that. Correct. Yeah. Good one, Garlo Party. Correct. And what about cost? What about cost? Medium. Correct. So now if you look at it, okay, let me put this in a different form. If you look at it, speed and cost are inversely proportional, more or less. If it's low speed, speed or cost are similar. If you look at it, both are favorable to me, right? So let me put this here. This is low. In other words, speed is low. In other words, here, cost is low. Correct? In other words, speed is low. In other words, here is cost is low. Here, speed is high, cost is high. Can I say that speed and cost have a similarity? Yes, no, maybe. Speed comes at a cost, right? That is also kind of proved here. So our tabular form is going very well so far, right? Now, let's go to graph. What do you think the speed of the graph is? Can you actually define the speed of a graph given this messed up diagram? You don't have a definitive answer, right? You cannot say it's medium also. It is completely dependent on the input, right? So can I say this is variable cost or a variable speed, right? Okay. What about complexity then in that case? Complexity. V is variable. Okay. Very high. Absolutely. This is like 0 point. It is probably negative also. I don't know. Right? It's probably negative also. It's very much complex for you to build. Okay. Yeah. Control. What about control? How much control you have over the output? 0. Spot on there. Very good. Oh, sorry. Spot on. Let's put a 0 in here. What about the next one? Cost. Spelling. I'm learning trigonometry. Okay. Cost is variable, right? It depends on speed. That's what I'm trying to make a point here. If it's low speed, low cost. If it's high speed, high cost. Right? So essentially here, I'm probably getting a 1 point here. No, not even 1 point, probably 0. Like, I don't know. We can't give a point in here. Let me put it here for now. The 2 points here. It's probably -1. So like unfavorable, but also that might have a use case. Correct? We're just exploring the possibilities. Now, human in the loop. This is very interesting. I love this. What about the speed? Speed is actually -1. Like very, very low. Why? Because let's say if you have sent something, if an agent sent something for an input from you instantly, let's say if you give an answer day after tomorrow, don't you think that speed is dependent on you technically? Government office. Okay. Now, what about complexity? Complexity. Low, very simple. So it gets a 1 in here, right? Okay. Next, what about the other one? Control. Correct. Control is very high. So 1.51 that works. Yeah. What about the cost? Very low. Okay. So this is also ideal. So let me put this 0. even if it's very low or very high or something. Let me put everything in 0 and 1. Now, if you see, this also has 3. Okay. This also has a 3 points. Now, if you look at the overall total, don't you think if I have a sequential agent with a human in the loop, or an orchestrator agent with a human in the loop, are my best lethal combo with regards to cost and efficiency? Right? Now, do you see why, although we have different agentic frameworks, do you see why only few are preferred most of the times? Right? You can do parallel also, but if you look at the cost of parallel, see the cost of parallel, it's very high. I'd rather, that's why I said, in terms of efficiency and cost, the combination of sequence with human in the loop or a manager in human in the loop is very much pocket friendly and high efficient. Make sense? Gaurav? Yes, and others? Right? Lovely. Awesome. Having said that, let's take a small 5-minute break. I think my throat is actually, I want a little water or something. Yeah? This 5-minute break, is that okay? Cool. Much expected. Okay. Cool. Team, can we have a 5-minute break? Hello. Okay, I think let's take a 5-minute break in here. I'm going to put a timer in here itself. Yeah, here you go. The timer, sorry. Here's the timer. Here's the timer, everyone. I'll see you in just 5 minutes. Audience on fire. Panelists retired. I'm not retired. I'm going to come back strong. Yeah. Yes, just give me 5 minutes. Okay, everyone, are you all back? Yes. Some of you never went away also. I know that. Okay, I think I'll stop the break in here. Cool. No problem, no problem. Yeah, cool. Now that we've covered agent orchestration, right? There are two things left on my plate, right? One, to show an interesting project and walk you through that, where I've built an agent and I want to go through the code pieces and help you understand different things. That is one. And the other one talking about MCP. Which one should I cover first? MCP. Okay, I'll give the option to you. It's a democratic country, so we will go with MCP. So MCP, here we go. Now, let's come in. We'll start with MCP and then go to your code. Go to our code. Okay. Now that we've understood all of this, I want to know your little definition, like whatever you've heard about MCP, like what do you think MCP is? What do you think MCP is? Don't give me complete full forms. Don't give me full forms. I know the full form. Okay. Okay, I'm gonna write the answers in here. Connection. Why is this? Connection between apps or agents is some of you say. Some between agents and tools and interface. Okay. Some of you say middleware. Okay. MCP is API for agent. Okay. Interesting. Integrations. Agreed protocol. Bridge. Any more answers? Some kind of a socket. Okay. Makes sense. So these are valid answers. Again, these are very good, valid answers. But let's get into the correct definition of MCPs and why they have come up in the first place, right? So MCP, okay, I'm going to put a chat on hold. Everyone, I'm going to put a chat on hold. Laser sharp focus for 5 minutes and then you go back to casual mode. Okay, laser sharp focus for the 5 minutes and then you go back to casual mode. Now, what is MCP? MCP is, let's say, if I were to book a hotel, right? What are the typical steps I follow? Probably, first selecting the destination or probably, clicking on maybe search icon of selecting the destination and probably the target city. I mean, the source, wherever you are going from, the dates, and then selecting a particular hotel and then making a booking. The process of steps or the sequence of steps that I follow for booking a hotel is completely different from the way I book a flight. Yes or no, maybe, everyone? Yes, no, maybe. The chat is open. The process of booking a hotel, at least from the UI front or the steps you navigate as a human, is completely different from booking a flight, right? And it holds the same for if you want to book probably a different venue, if not a hotel, maybe a resort, right? Now, the actions themselves are not too much complicated, although the actions within them are same, where are pretty much same, like figuring out what dates to book, what is the place to book, and book. Although these are pretty much similar underneath, the steps or implementation of how do you do this is differed from one app to another app. Correct? Yes, no, maybe, everyone. Now, let's try to simplify that same logic. Let's say if you want to send an email, maybe the APIs that you use, or maybe the like code piece that you use to send an email from a Gmail API is completely different from the way you write from an Outlook API, correct? Right? And let's say if tomorrow these companies change their implementation, it is your responsibility to go back and edit these implementations by your by your hands. Correct? Yes, no, everyone. So there are a lot of dependencies in here. There's no modularity given to me at my hand that, hey, I can work with your app, being an abstract form, like giving an abstract command and getting the job done without getting into the much of the implementation detail. Is that statement clear, everyone? There is no form or a method where I give an abstract command without me diving deep into the implementation details. The action should be performed, right? So this ability of taking a command apps and without diving deep into the implementation, but still getting the action done is given by this MCP. What does mean by MCP? I'm going to define that in here. So let's say here, this is your LLM. This is our LLM. Sorry. Yeah. LLM. Now, if I'm trying to give an input to this LLM in the form of a prompt, of course, this prompt, the prompt I am going to ask is all about write an email via Gmail. Okay, this is my prompt. Now, this prompt is input, especially in the context of an MCP. What happens is this LLM, this LLM is going to get or connect to a server. Let's call it server for now. Okay, where there's a piece of logic or piece of code or implementation or something that does the actions from abstract command to abstract command itself. So this is called Gmail MCP. So what MCP stands for is, Model Context Protocol. Model Context Protocol. Okay. What do I mean by that? Like I'm defining a protocol to give my model a better context. I'm defining a protocol to give my model a better context from very different apps across the internet. It could be Gmail, it could be Outlook, it could be Slack, it could be yada, yada, yada. Right? What I'm trying to say is this is how the MCP structure will look like. Please watch and carefully pay attention to this. First, any MCP will have, of course, its tool name or its MCP name and its description. This is your entry point of the MCP. This description is, this server or MCP does all things Gmail, let's say. Okay. And now every MCP will have a set of tools. Okay. What are those tools? Tools are nothing but actions. Send email, probably read emails, draft email, etc., etc., etc. And now every tool will have their own description. So they will have some kind of a, what do you say, syntax that says something like @tool. Now you are going to write a particular description for this tool, probably a tool description. Something says, what is the tool name here? Let's say @tool, I'm going to write send email. I'm going to zoom in a little bit in here. I have to expand this. And this description says that this tool sends email via Gmail API. Via Gmail, that is all it is. Now, right below this tool, there's an implementation for this tool. Implementation is nothing but a piece of code that uses Gmail API, to send the email. Okay. And the same structure will be followed for different tools. You'll have the same structure for reading emails, drafting email, where you have tool description that says this tool is going to do that, and implementation on what it is going to do that, how it is going to do that. Is the structure clear, everyone? I'm going to give a use case now. Is the structure so far clear? the description of the MCP, tools available in that MCP, and the implementation of these tools with a description. Now, you might be asking, Akhil, why this description is super important to me, right? Because remember, LLMs give us a very bigger capability to kind of comprehend a natural language, right? Yes. So if my command says write an email in Gmail, given all the available MCPs that are attached to this LLM, it will not go into the go and read all of this. The LLM will just go and read the description. It will say that, oh, this I have an MCP that does all things Gmail. Make sense, everyone? Yes, no, maybe. The description is very important for an MCP. Now, once that is done, LLM will now go down the path of this. It's like, okay, once this is done, it will read the tools. Do I have send email tool? It will figure out that it has a send email tool. Now it will go and read the description of that send email tool. It feels that, okay, this tool is going to send email via Gmail. Now it will respond that, Akhil, I have a tool that I'm going to use. So will you give me a permission to actually give or run this action, right? Now LLM will go and directly run this implementation on behalf of you in that particular MCP server. So now you have automatically taken an abstract command without going into the implementation or writing the implementation off the fly. You're just implementing that action just by definition. Make sense, everyone? Right? This is not an agent. This is not an agent. This is an MCP server. So this is out of my LLM. This is out of my LLM. Right? An agent is part of where I have an LLM. I have some kind of a database attached to it. I have some kind of a tools that I've hard coded with that LLM to directly talk to them, not via MCPs, right? And probably I have some kind of a looping mechanism attached to it. So then this black box becomes an agent, not MCP. Okay, makes sense? Gmail MCP, you can consider it's more like a tool, but an external to an LLM. Right? You can also consider you can also connect MCPs to an agent because it has LLMs by definition. Correct? Everyone? Yes, no, maybe. So what I'm trying to say is, when I'm trying to give a command to an LLM in a natural language, that command is taken, and let's say if I've connected a Gmail MCP to my LLM or my particular interface, right? Now this LLM is going to first, instead of, so what is the first reaction for any MCP, sorry, for any LLM? If I write an email via Gmail, it'll probably spin up a piece of code and gives that, hey, here's the Python code that lets you write email, send email, and probably give a code. And it also says that, hey, unfortunately, I don't have that power, but here's the Python code that can get the job done for you. Have you ever faced this situation? Yes, no, maybe, everyone. When you asked for something to do an action, it will say, unfortunately, I don't have that power. Here's the Python code. Why it doesn't have power? Because it does not have tools at its disposal to actually use it off. So now MCP is more like an external tool. Instead of it generating a piece of code, it is using a piece of code that is already implemented or well defined in this Gmail MCP tool. It takes that command, redirects, reasons out itself to find the necessary tools, and that reads their description, and then just implement that piece of code. Correct, Afsar, you're correct. Make sense, everyone? Is this clear? Hello, everyone. Yes, no, maybe. Perfect. Now, there's a biggest flaw in an MCP. There's a really big flaw in MCP. Can someone figure out? Can someone figure out? No, API keys, everything is handled. Not a problem. Nope. No personal data. No, like essentially, like when you're connecting to Gmail MCP, you will go via the standard Gmail OAuth sign in process. Everything is pretty much standard. Like everything will happen as per the standards. But this is the biggest flaw in MCP protocol itself. Can someone tell me? Risk of hallucination? No. 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 Nope. Nope. Feedback. Nope. Okay. Can I? Okay. I'm gonna. Yeah. One answered is very good. Very good, Rahul. Very good. Yeah. So the answer is okay. The flaw and the answer is there is something called as prompt injection. Prompt injection or code injection, in other words. Okay. There are different forms of this, but what is this? Is because even though the tool description says this is going to send email via Gmail, in the code, let's say, if it also sends the same email as BCC to someone else in the code, but the description just says send email via Gmail. Makes sense, everyone? If the implementation has a virus, let's say, or some kind of a attack on you, the implementation is not giving me any detail. The LLM is kind of dumb as not looking at the implementation, but just looking at the description and executing it. Makes sense, everyone? Everyone? Yes, no, maybe. Yes. So then how do you avoid this? Then how do you avoid this by definition? Right? Let me give you a very simple example for you to take it forward. Right? So how do you actually order food? Like when you're picking up food, like let's say, I'm sure you must have used food delivery apps or something. Then what kind of food you have usually ordered, and how do you decide on a food from a restaurant? Come on, give me your answers. Everyone. Yes, absolutely. Ratings, brand, reviews, bestsellers, price, of course, the main important part, right? Absolutely correct. Nearby, etc., etc. Now we will do the same exact thing while choosing an MCP. How are we supposed to do that? Let's go to an MCP marketplace called Smithery. Smithery AI is one of the MCP marketplace that you can just use it off, right? So here, this is a marketplace where companies have developed their own MCPs, and people like us also developed our own MCPs and just deployed in here. Okay, Smithery has their own level of checks, ensuring they're compliant enough. They have all these guardrails kind of a thing done. But still, there you might find some kind of an outlier that is trying to go around about this and get still inject some kind of a malicious MCPs. So let's say if I want some kind of a, let's say, I don't know, maybe a Supabase MCP. Supabase is an open source, Postgres SQL library. You can use it for free or you can use it with some paid subscription, right? If I click on Supabase, now if you see there are so many Supabase MCPs available here from different people, okay? Now if you closely watch this particular thing, number one, which one would you pick out of all of this? Which one would you pick out of all of this? Can you give me a row one, column one kind of an answer? First one. Why? Why? Because if you see, this is brand, Supabase official vendor. So one of the things we have checked is brand. I'm going to put a tick mark there. Okay. Ratings or reviews. So if you see this is used by 34,000 people last time. Okay. So this is technically serving as a rating and review mechanism. and also maybe in some words bestseller, right? And the other one we should look at is, and the other one we should always look at is if it's a remote. So if you see it runs remotely, no local installations needed. So this Supabase server is maintained by the Supabase company itself. Okay, this Supabase server is maintained by the company Supabase itself on their own cloud. So you don't have to install any local MCPs into your system. So if you're installing something, there might be a malicious attacks from installations also. So the other third round of check you should need to have is remote. So essentially, in terms of selecting an MCP, you'll select for these three things: official vendor, number of times used, number of uses. Yeah, used, let me type that. And the other one is remote only. These are my recommendation based on my experiences. There will be times, even if it is not there from official vendor, but it is remote, but number of times used is more. So you'll have to take that call. Okay, is this reliable and like really important for me to actually connect into my LLM? Makes sense, everyone? Everyone, is this clear? Right? So this will ensure even if you're using MCP, you are actually using very solid MCP that accelerates your performance, that improves your experience with all the external tools and gets the job done without having any problem. Clear? Everyone? Yes. Wonderful. Wonderful. It's not like an SDK. No, it's completely a server where you have, this is the kind of a protocol. This is the kind of a protocol. This is maintained by the official vendors. They will have this implementation taken care, because if tomorrow instead of Gmail version 3, if you want to use version 2 instead of version 3, Google will update and come and update this particular implementation themselves. So that way, LLM will always get an top of the class, state of the art, latest models when they are executing those actions by definition. But there are rules building MCP also, right? Correct. Yes. Okay, screenshot time, please. Okay, here you go. Here's the screenshot time. I'm going to delete this one. I'm going to just put this in here. Sorry, 1 second. In here and zoom in a little bit. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, I break the pattern once again. Correct. Yes, I hope you've taken the screenshots, everyone. But yes, I have a bonus for you. I have a bonus for you, as I've told you, right? I have a piece of code that does. So what did I do? I'm going to explain that here. I've written a piece of code that's more like an agent, which takes a topic that is in my mind, right? I want to probably learn about the topic and probably, understand a little bit more of that topic. It'll take a topic, research, write, validate everything, and then it will create a multi-speaker script. Once it creates a multi-speaker scripts, it'll convert that into a podcast. It'll convert that into a podcast. So where I can just plug in my earphones and just go for a walk and listen and learn about that topic. Is this interesting use case to have, everyone? Of course, this was interesting to me, just like Notebook LLM, correct? But at my command, my command, right? Yes. So let me walk you through the piece of code. I'm gonna, of course, share that resource with you, right? As I said, that's the bonus for you. I'm gonna share that repository with you, right? So you can actually work, tinker, play around with this repository. 2-person speakers, Jane and Joe. Those are the characters. Okay. So I'm gonna walk you through the piece of code so you better understand what are the scripts that are playing different roles in that particular project. So next time when you're tinkering, you know exactly which file to go and tinker. Make sense? Everyone, are you excited? Are you excited? Drop your favorite emoji in the chat. Wonderful. Okay, let's go. Fantastic. Now I'm going to share my different screen. Give me a second here. Yeah. This is more like our VS Code alternative, but a different one. Now, this is the kind of output. I'm going to show you the output first, right? Let me share this with sound. Yes. Now, here you go. One of the output. Let me check. Okay. I'm going to stay mute for a moment so you can hear the voice.
The future of AILMs.
Welcome back, everyone. This is Joe.
And I'm Jane. Today, we're diving into the latest and greatest in the world of AI large language models, or as we like to call them, LLMs.
Because who doesn't love a good acronym, right?
Right.
How is that, everyone, so far? Is it very natural and like super cool podcasty vibes? Must, wow, awesome, damn, yeah. Correct? Lovely. Yes. So this is the kind of output we're going to create. And we're going to use a framework called Crew AI, right? I'm sure I think you've got accustomed to that a little bit in the morning off session or something, right? Now, how does Crew AI work? What is the typical structure we need to follow? Okay. So let's go to this agents.yaml that I've written in this podcast file. I have a configuration file where I have to configure the tasks and agents predefined. Like this is the structure that Crew AI has suggested. Only then it will work accordingly. Right now, I'll go to my agents. And if you see, these are the three agents I have. One is researcher agent, reporting analyst agent, and a script writer agent. Okay. Now, if you see closely, every agent will have a role, a goal, and a backstory. Role simple. Given a topic, I will say you are a senior researcher of that topic. If it's an AI LLM, I'll say AI LLM senior researcher. So this is a variable here. Okay. Now goal, find recent releases, articles, topics in progress about this particular thing. Again, the topic is variable. Now backstory. Why is this backstory important? Because assume this is a human. Let's say if someone is trying to fill in the shoes of someone who has just now, went away from our company. Don't you think we'll give them a backstory or a context about what they are supposed to do, right? Consider it in that similar fashion, right? So backstory is more of giving a context so the agent knows what it is supposed to do technically in a little more abstract form, like roles and responsibilities form. Okay. Now, next, it is important for us to define the tasks that these agents are supposed to do, right? So there is a research task, there is a refined research task, there is a reporting task, there is a scripting tasks that I've defined. And every task will have a description, the expected output, and which agent should it map to, right? So an agent can have multiple tasks. So it's like one-to-many relationship. And that relationship I'll have to define in here, in this task.yaml file. Okay, now here in the research task, I'm going to say conduct a thorough research about the topic I give. Make sure you find any interesting and relevant information given. And the current date is current month and current year because I have to find the recency. Remember, this is how I inject a recency into the agent by definition. Now, expected output, a list of 10 most relevant news and progress on topic with summary, details, and excerpts and more. That is the expected output from a research agent or a research task. And I'm going to assign that task or map that task to a research agent in here. This is just a mapping. We have not assigned it yet. So we're just saying only research agent is supposed to do this task, not anyone else. We're just mapping it there in terms of roles and responsibilities. Is it clear so far? Difference between goal in agent and description in task. It's like, for example, if you have hired someone who want to grow your company in terms of, let's say, some sales, right? For him, the goal is improve the sales in the next quarter. That is the goal of an agent or a human in that case. The task at hand Every task will have an expected output. For example, he might have to hire a team of 10, right? Expecting that he will get probably 1 month sales better from the from the day he have started. That is the expected output of that particular task. Correct? Yes. Now, there's a question, there's something, the LLM is trained on a dated data, then research will also be dated also. Correct. So since LLM has a cutoff date, that's the reason why I'm giving current month and current year as the context. So it performs better. Now, once that is done, you'll have to go to crew.py, and this is where we will initiate all of these agents and tasks. So we'll start with something called @crew base, and I'm going to create a class podcaster crew. I'm going to define these or initialize these agents, right? This is the structure that given to us by Crew AI. Just ensure these are just taken from there and used. And before kickoff, I'm ensuring that I'm going to create a new path in my computer, so these podcast files are stored. Okay, and I'm going to talk that I'm going to create a new directory essentially. And now I'm also initializing the tasks. I'm initializing agents, I'm initializing tasks. Everything is pinned up. Now it is time for me to create the crew. Right here, I start the crew, say that, hey, agents, you are my crew. These are your tasks. This is you are supposed to do a sequential logic, right? And I'm saying whenever you're doing it, be verbose. So verbose equal to true necessarily means that if I run this command or if I run this agent, I will see a lot of like all the things that it is doing behind the scenes as an output, saying that scraping for so and so resource, trying to crunch down this thing, trying to summarize. So whatever it is trying to do, every step behind the scenes, it's trying to be a little more verbose on the output. Verbose is essentially a logs, correct? Right? Now, once that is done, we'll come to main.py. In the main.py, we will run the crew with, remember, topic AI LLMs, current month, current year, and I'm going to say podcaster crew kickoff. And the inputs are this input. This ensures if I do main.py.run, this is what it happens. Make sense, everyone? Right? Of course, I've given you a complete high level overmap. Like, there are a couple of other things that you can work around. But one important tool here is I've created a custom tool called Gemini Voice Tool. I've created a custom tool called Gemini Voice Tool, right? Remember, for agents, I will have to write these tools. So agents will have a tools attached to them, custom developed and attached just like this. These are not MCPs if you look at it. MCPs will have a tools by themselves according to their apps. But agents, I will define the tools like this, right? I'm going to say, hey, here's my custom tool. You're supposed to use Gemini 2.5 Flash model. This is for multi-speaker approach. So you can see multi-speaker voice config. One person is Jay, one person is Jane. Like I'm using the voice core voice name as Puck and core. These are the model names or voice model names in Google. This is the standard piece of code that I've taken from Google TTS multi-speaker mode and just put it as a tool and gave that, hey, this you are supposed to do this at that particular step. Clear, everyone? Makes sense, right? Yes, so this is how you create a sequential agent with well-defined tasks, descriptions, roles, expected outputs, instantiate them or initialize them, connect them, run them with a custom tool that will kind of clear out the mapping or understanding of how agents are built. I'm going to give you this piece of code to you, all of you, right? You can do that exactly in your system, right? Yes. But for me to do that, I want all of you to type down your favorite food in the chat. I want all of you to type down your favorite food recipe or anything in the chat. Wow, vada pav, pani puri, biryani, chow mein. Okay, awesome. Okay, I think it looks like I'm very much hungry now, looking all of this. Cool. Yes, right. Awesome. I have enjoyed all your this thing. I'm going to share the resource with you right away. And having said that, that is where I'm going to stop my magic show. Right? Just give me a moment. Just give me 1 second where I can find this repo. It's in one of the things that I have handy. GitHub. Yes. Copy the link. Here you go, everyone. I'm sending it to everyone. Correct. So that is your resource. And this is where I end the magic show for the day. I hope you've got the resource. Yes. Amazing magic show. Loved it. Thank you. Thank you. Thank you. Wonderful. 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 Amazing magician. Thank you so much. Om, are you around? I think he's probably away from the keyboard once again. Let me check. Thank you so much, everyone. Thank you so much. I think we have still Sham. Thank you. Thank you so much, everyone. As I've told you, right? Like your involvement improves the profound value of the session by by leaps and pounds. So thank you so much for being super interactive, right? And I'm gonna share my socials in here. Give a moment. Sorry. 1 second, 1 second. Yeah, I think I've got my socials in here. Okay, yes. Everyone, these are my socials. I've recently started my YouTube and Instagram game as well. So I'm doing a little more fun and some kind of interesting insights or tips as I learn along across all the AI things, right? So that is what it is. Feel free to connect. I'll be happy to kind of collaborate, talk, and everything, do along the scenes in that aspect as well. Right. And having said that, I'm just waiting for the Om to come in. I'm waiting for Om to come in so we can take over the session probably. Probably he's having some internet issues apparently. Think some internet issues at his hand. I'm trying to contact him. He's trying to figure it out. Yeah, morning session resources will be shared as soon as the Om is here. Don't you worry. All the resources will be shared with you. Yeah, I think Om's internet is connected back. Hello, Om.
Oh yeah, I don't know what was happening. I tried multiple times, but yeah.
Yeah, finally is here. Yes.
Okay, folks, how was this? How was this second session so far? Oh, let me also launch the poll once again. One second.
100 on 100. Thank you. Yes, the C side is here, everyone. Please take a moment and answer. It will be very much helpful for me.
Yeah. The Magic Man, all are great professors, lot of effort, awesome, complex, excellent. It was good. Okay, got it. Folks, let's do this. Click on the poll, let us know how was the session. And also, what we would do now is put your questions in the chat. We'll take the questions for next some time, 10 to 15 minutes as it may come, and one that we could take, and then we'll come back to the final part of the day. There's one final part remaining. We are at 6 p.m. The session will end at about 7 p.m. And yeah, what is the name of the editor he used? Xcalidraw? Yeah. There's a platform called Xcalidraw that you can go to and use. It is a free platform that you can look at. Okay, then what we have? Can you share the whiteboard? We'll share that. We'll share that, folks. We'll share that along with resources. Why do we need MCP? Okay, we'll cover that. How can we get certificate? Folks, no logistical questions. I'm not going to answer it right now. Now is not the time. We have 1 hour remaining. Okay. Okay. Was it VS Code? It was not, Rajat. It was not VS Code. MCP is agent. So 2 questions, Akhil. Why exactly MCP is required, and MCP versus agent?
Okay, cool. So remember everyone, I think I'll go back to my conversation of how do you talk to different apps like Gmail and Outlook, but perform the same operation of sending an email, right? For an LLM to understand that logic, it will have to spin off a, like, what do you say, a piece of code every single time, right? According to the, of course, the latest standards and all that. And that piece of code sending an email is like, you don't have the LLMs don't have an environment or a shell to run by its own and send that email, right? For the agents or LLMs to understand our natural language, to take that action, you need some kind of a compute or a server which can does that implementation job for you, right? So that is the reason why we are trying to offload all these modular pieces of code or actions for a certain app and naming them under the same MCP tool. So a Gmail server, MCP server, will give all the tools such as sending an email, reading an email related to that. And Outlook MCP server might give you the same operations, but their implementations are different, right? Now, if you're using, like when you ask about agent by definition is all about memory, how much it can remember the past conversations. Context, memory is the context. And the LLM behind the scenes, like what kind of brain are you using? Is it a GPT-5, GPT-4, etc., etc., and how you have configured the tools to it, right? If you are writing that implementation of writing a Gmail tool or Outlook tool with a piece of code and connecting to your LLM and calling it an agent, then it becomes an agent. So if you see my podcaster example, I've created a custom tool myself and plugged into my agent, right? So if I'm doing that, then it's an agent by definition because it has an access to tools. But MCPs is an extension of tools which are external to you. So you don't have to develop all by your own. But still, if you want to call that framework as an agent, sure. Because at the end of the day, agent will perform actions. So if you are using LLMs and MCPs, and if you want to name that as a agent in bare bone structure, yes, you are correct.
Got it. I think somehow this happens almost every time. People get confused between agents and MCP, and that happens. I think you'll have to do that. So somebody is asking, is it mandatory to have MCP server for every LLM? Pallavi, the answer is no. LLMs now have MCP server so that they can access your personal either document or data or whatever you want to have access to. it's not necessary, but since there's a lot of competition to make it for the tools to have much more advanced feature and your personalized information is why they have MCPs. And MCPs is how they take action, as simple as that. What is the name of the code editor that you were using or showing?
Cursor.
Okay, instead of RAG, can I use MCP? Karthik, you have mistaken the both. You can't do that because the function of RAG and MCP is completely different. RAG is a model that you have trained with your own data. MCP is a hand of an AI model, which gets the job done. So it's not same. Any
Correct.
recommended AI agent or MCP platform that can be used with drag drop no code abilities?
You can use Smithery AI. That is an MCP marketplace. You can just connect it to your platforms that you're using.
So folks, we showed you a framework list, right? A very big framework list. We told you about function and tool calling. There are two platforms, Composio and Smithery. Smithery is what he's talking about. We'll send you the names of it as well. So can I assume MCP eases job as others we have to create custom tool?
Correct.
I can say that, yeah. What about embedding? What are embeddings? How do you simplify that?
Okay. So you can consider embeddings as or a process where you're converting
Hello, everybody. How you doing? Thank you, people. Thank you so much. I appreciate that. We have a wonderful show. Okay, all right. Thank you. I love you back. All that stuff. I know it's a little verklempt. I know it's our last show of the season. I know it's our Thanksgiving show. I've already started my baking. I know. I'm going to do it myself this year, Thanksgiving. I am. I don't know. I probably should not have asked GTP how to do it. Though. No. I asked them, how do you roast a turkey? It said, tell it looks like a chicken who can't afford Ozempic. But yeah, we always have our little winter break. We will come back in January as always. We were back January 23rd. Mark that in your book. And when we do come back, this all will be an incredible ballroom. I just want to. I kid the president. Oh, boy, it was Muslim week at the White House this week. No, first he had Mohammed bin Salman, the Crown Prince of Saudi Arabia.